On winter fronts in Europe, soldiers learned quickly that exposure was as lethal as enemy fire. Mud froze, boots stiffened, and numb hands made even simple tasks dangerous. Open flames were forbidden at the line. Firelight drew snipers. Smoke invited artillery. Yet men still needed heat to keep circulation, prevent frostbite, and survive night watches that stretched for hours. Out of this necessity emerged a little-known solution carried quietly to the front, a trench heating brick that produced steady warmth without flame, without smoke, and without revealing a position. This was not folklore. It was a controlled, engineered response to the brutal physics of Cold Warfare. How militaries arrived at a heat source that could not betray a position. By the early years of industrialized trench warfare, armies understood that conventional fires were tactical liabilities. Even small flames could be detected at night from hundreds of meters away. Smoke drifted unpredictably. Sparks rose above parapets. The solution required heat without combustion in the visible sense. The answer came in the form of compressed heating bricks, often made from charcoal fines, mixed with binders and small amounts of oxidizing salts. These bricks did not burn with flame. Instead, they underwent slow oxidation, producing radiant heat at low temperatures. To the eye, they appeared inert. To cold hands, they were life-saving. So, why did these heating bricks behave so differently from ordinary fuel? Well, the key was really in their density and how they restricted airflow. Unlike ordinary charcoal, which burns with a visible glow because oxygen can reach the carbon freely, these heating bricks were compressed tightly, making it tough for oxygen to get in. Once they were ignited for just a moment and then smothered, they slipped into this smouldering state, producing heat without any flame. Some versions, interestingly enough, were built to be reheated over and over again. Others, though, were single-use, meant to keep going through a long night watch. Because there was no flame, you didn't get sparks, no smoke plume, and none of those sudden temperature spikes that could crack equipment, or worse yet, draw unwanted attention. This was, in a way, controlled chemistry put to work for tactical survival. Now, how did soldiers actually use the trench heating brick? Well, typically, the brick would be ignited briefly with a match, or perhaps over a stove in a sheltered spot, then enclosed right away in a metal container, a mess tin, or even wrapped up in cloth. Once it was sealed off from direct airflow, it would shift into a slow, steady heat source. Soldiers placed it at their feet, inside coats, or beneath wooden duckboards to warm the frozen ground. Some units issued metal sleeves specifically designed to hold the bricks safely. Others improvised using ration tins punched with minimal vent holes. The heat output was modest but steady, exactly what was required to maintain circulation without creating thermal shock. Why the brick mattered more than comfort. Cold injuries incapacitated soldiers silently. Trench foot, frostbite, and hypothermia reduced combat effectiveness and forced evacuations. A man who could not feel his fingers could not reload, signal, or defend himself. The heating brick kept extremities functional. It allowed soldiers to remain still longer, conserving energy and maintaining discipline. In this sense, it was a force multiplier, not a luxury. Commanders understood this. Heating bricks were issued selectively where conditions demanded the most. Now, how did this technology differ from the chemical hand warmers that came later? Well, modern chemical warmers, you see, rely on the rapid oxidation of iron powder when it's exposed to air. In contrast, those old trench heating bricks operated on much slower carbon oxidation, with oxygen carefully restricted. Sometimes these bricks could even be reused, and they were certainly far more durable under the harshest conditions. They also, produced less moisture. Condensation inside clothing was a serious problem in those cold trenches, leading to dampness and, unfortunately, even more heat loss. The brick's dry heat really helped reduce this risk. Plus, the sheer simplicity of the design made it remarkably reliable, whether it was mud, rain, or freezing temperatures. Now, let's talk about how similar principles can still be applied safely today. The historical lesson here isn't to just recreate the brick blindly, but rather to understand the principles behind it. Dense fuel, limited oxygen, and of course, controlled heat output. These remain the foundation of safe, low-visibility heating even now. So, in modern emergencies, insulated hot water containers, catalytic heaters designed for enclosed spaces, or purpose-built charcoal heaters with, strict ventilation controls all reflect the same logic. The trench brick, it teaches restraint. More heat is not better. Steady heat, that's what matters. Understanding airflow control and insulation. Well, it remains absolutely critical for any cold weather survival planning. Why did this knowledge fade after the wars ended? Post-war militaries moved toward mechanization, heated vehicles and powered bases. The need for individual low-profile heating just declined. Civilian life, followed a similar path with central heating and insulation. As a result, the trench heating brick became a footnote, remembered by veterans but rarely recorded in detail. Its quiet effectiveness, it actually worked against its legacy. What the forgotten heating brick reveals about wartime ingenuity is, I think, truly remarkable. This tool embodied a core truth of survival under fire. The best solutions are often invisible. They do not announce themselves. Instead, they work steadily in the background, keeping people alive long enough to endure. Understanding the trench heating brick is not about nostalgia. It is about recognizing how disciplined engineering and environmental respect saved lives when technology was limited. If you value serious history grounded in practical reality, then please support the work of this channel. Subscribe to Echoes of Valor. Share this guide with fellow history and preparedness enthusiasts, and help ensure these overlooked lessons are preserved for those who may need them again.